Today, while we're waiting for people to come in, today I'm going to try to make up breakout rooms. I've shared with you already a Google folder that has, I've shared it with you and your partner, so you don't have to make another copy. You'll just do all your work right there. And hopefully we'll be able to use the breakout rooms. So you'll use that instead of Discord, because I don't think the district wants us to use Discord. We use the breakout room as the channel for the voice and pictures, so you can see one another, kind of a split screen, and then the Google whiteboard that you can work on together. So it's been working really well for the other classes, so I think it'll work pretty good today too. Can you believe it's snowing? Is that crazy or what? Can you believe I have a neighbor that was actually mowing while it was snowing? I think that's called denial. I was going to get a picture of it, but didn't make it.
Anything can happen in Indiana.
Yeah. Go to bed. Can you please change your name so I know who you are? Because I'm going to be putting you guys in breakout rooms and I need to know who you are, so I put you in the right group. So
Okay.
I don't know exactly how you change your name. I think you have control of that.
Did you get new furniture, Taylor?
Oh, he's had that furniture before.
Yeah, it's just like the office background I usually use.
All right, I think we'll get started here in a minute or so. I think I'm going to go ahead and get started since most people are here. There might be some more people come pretty soon. All right, today I'm going to try to use breakout rooms. We're not going to use Discord because I don't think the school district would approve of that. I think the breakout rooms will work just fine. So let me explain what we're going to do. Okay, so get this out of the way. So, oh, I got to share my screen, of course. Okay, so in the agenda for today, we're going to be whiteboarding worksheet 2. And I've shared with you in your Google Drive, just this morning, I shared with you whiteboards for worksheet 2. And I put you in groups. And so you can kind of see the people you're working with. Those are the whiteboards. So here in a moment, what I'm going to do is I'm going to form up breakout rooms that, for instance, one breakout room is going to have Riley, Matt, and Josh in it in one breakout room. That way, what I'm thinking is that each group can do a split screen. One side will have their face and they can talk to one another while they're all working on the same whiteboard. So the goal of this is not to divide and conquer. That's not what I want to do. I want to just take our time. We might not get that far. I just want you to kind of understand how this is going to be working until we're done with the school year. Because I want to do whiteboards more like this instead of me lecturing to you. I really don't like that at all. Okay, so let me stop sharing. And let me see if I can go ahead and start forming some, whoops, let me see if I can form some breakout rooms here. I forget how many I need. 1, 2, 3, 4, 6, 10, 10. Now it's going to take me a while because I'm not really proficient at this, so give me a second here. Okay, so there it is. Okay. Josh. Okay, and maybe I'll do it this way. Oh, I thought I saw Jack here. Jack's not here. Okay. And you.
Jack never seems to be here.
No, that's all right. I'll just make his life fun later on.
It's because he has a girlfriend, Mr. Bestie.
Oh, I'll let his parents know that.
Hangs him.
Maybe his parents aren't aware of that. I'll let them know that. Okay, and let's see.
He's actually under house arrest, Aiden. He's got no excuses.
He still got a phone. We can take that away too.
Mark. Sorry, it's taken me a while here. Sorry. Ben Spencer.
Pretty sure he's asleep right now.
Oh, sweet. More information you guys can give me, more I can make his life fun.
No, he has another Zoom call, I think, at 1:05.
Oh,
that'll be fun. Yeah.
he doesn't have calculus though.
He doesn't wake up until 3 p.m.
Kobe, shut up.
Shut up, Kobe.
Robert's not here either. Okay. Let's see. Kenzie, Michaela. Sorry, it's taking me a while. Kevin. Taylor. Okay, I'm opening up all rooms right now. So why don't you go ahead and go in there.
No.
Adam, did you get a join code, or I think you want to hit that join probably?
That room with Robert?
Yeah, yeah, you are, but he's not here, Christian. So I hope that's all right. That way you're not working by yourself. So,
All right.
So what I thought you could do, Christian, is you can go ahead and open up your whiteboard and work on it, while Matthew and Adam kind of work on their whiteboard. But you can all kind of talk together and kind of run ideas past one another. Okay. All right.
All right.
Probably like the direction where the thumb is would be to the right. So yeah, I think it's up.
Is it going okay?
Yeah.
I think so, yeah.
Who you got there, Riley?
Oh, this is my niece.
Hi.
Henry, can you say hi?
Nice. So are you babysitting?
Yeah, my brother, they're all outside doing yard work right now, so.
Can you believe I had somebody mowing? You don't have somebody mowing there, do they?
Oh, well, I'm in Alabama right now.
Oh, you're in Alabama. Oh.
Yeah, so it's like 60 or 70 degrees right now.
Oh, okay. I'm kind of hating you then. All right. All right. All right. So it's working okay then?
Mm-hmm.
Oh,
Okay.
yeah. Oh, Mr. Infesti, one question. So on the picture, it's got a circle and then it's got the negative sign in the middle. Does that mean, is it coming out, or did you just use the circle to encapsulate the negative?
Let me, because I need to look at it. Let me join your whiteboard really quickly here. All right, so that picture is an electron. That's what that is. That's an electron, so it's got a negative charge. And so that negative charge is moving to the right, and you've got a B field also to the right. And so what your goal is, you're trying to figure out which direction the force is on that charge. And you only have to draw one vector, one arrow. You're going to draw that one vector right on that circle, right? So whichever way you think that electron is going to get forced.
Gotcha.
Okay?
Okay.
Okay.
Mhm.
So you want to think about right-hand rule, okay?
Yeah.
Thanks.
Yep. Everything going okay?
Yeah. Are we supposed to just go through the worksheet?
Yeah, just do number one right now. And
Okay.
then, I don't know, just sit and talk or whatever, okay? So number one, what that is, you have this electron that's moving to the right. Well, it's maybe not electron, it's got a negative charge. It's moving to the right, and the B field's also to the right. So you're thinking of how do you use your right-hand rule to figure out the direction of the force. And right there on that circle, you're going to draw some force vector. Okay?
Okay.
All right.
All right. So
Exclamation points.
You guys
Which
good?
route? No.
Well,
Yeah, we
not
got
exactly.
Any questions or anything?
it's into the page, right?
No, you're only doing number one.
Okay.
I thought that was number. I thought number one was what you're supposed to.
So you're all good?
No. But it's okay.
Wait, this is the thing where your thumb ports the direction, and then you're doing the back of your hand, right?
Yeah,
is
but
the force.
so the thumb is pointing to the right. Is that correct? If you're looking at the
Yeah.
picture?
Yeah.
And you're right, you're going to use the back of your hand for the force, but your fingers also have to point to the right.
Yeah. So I was like, this is weird.
Yeah, I couldn't do that.
So how much force is that then?
So it's out of the
Zero.
page.
It's zero, right?
Oh, okay. Okay.
What?
Cool. All right. Nice.
Okay.
All right. Thank you.
We'll go with it.
So Riley, you're in Alabama. How are you going anywhere? I thought you weren't supposed to go anywhere.
Yeah, so they just had a tornado come through
Oh,
Alabama. So we've been
wait.
helping them.
Was that in Alabama?
Yeah, it was, yeah.
So was
So
that
we-
that was it? Did it hit your family's house?
It hit a little bit, so we've just been helping them like clean up and like we helped them make some improvements to their storm shelter and stuff like that.
So is everybody okay then down there?
Yeah, everybody, it didn't hit Tuscaloosa too hard, but they like it definitely hit some trees down and stuff like that.
So that was just in the news then just the other day.
Yeah.
Oh, wow. Well, I hope they're okay and you guys are okay too. Let me check the breakout rooms, make sure everybody's back. Okay, so I'm hoping that worked okay for you guys. before, what we're going to do here in a second is just like in class, we're going to present whiteboards, except I'm not going to take the time to go around and look at everybody's whiteboard. We just don't have time for that. So what we're going to do is we're going to take a volunteer, I'm hoping. But before I do that, to get attendance, I need to, is it possible, like Jack, Adam, Christian, can you guys turn on your camera? Because I need to kind of get attendance. And so I'm gonna take kind of a picture of you in a second.
Come on,
Hey,
Jack.
I don't have my beauty face on.
That's all right. That's all right.
Yeah.
It's not like one of my other classes when I took the picture, somebody was yawning, so that was a little embarrassing. Hey, Jack.
Hey, Jackie.
Jack. Oh, that's just nice. All
Where
right.
is he?
Okay, so on a count of 3, 1, 2, 3, smile. Okay, thank you. And I just need to save it now.
Hi, Jack.
And I will do it again at the end of the period. Yeah, they were talking smack about you, Jack. Let me tell you.
He's gonna leave and go back to sleep.
I set an alarm for 1.
All right. Okay. So does somebody want to share their whiteboard with us? The faster we get these whiteboarded, the faster we're out of here. So the way you share is at the very bottom of the screen, you hit the green share button, and then a pop-up will come up and you just click the blue share button. And all you're going to do is show us your whiteboard that you have on your screen anyway. Okay, Kevin, thank you.
Yeah, Kevin. Kev.
So just talk to us and tell us how you figured out the answer was 0
Okay.
there.
I use the right hand rule, and since velocity is pointing is the middle or pointer finger, B field is the middle finger. You can't have the velocity and B field go in the same direction.
Okay.
0.
Nice. So yeah, you're going to see different versions of the right hand rule. So if you look online, if you look at like a YouTube video or something, they'll show you. I never could quite do that. Couldn't quite figure it out. For me, it works easier to use my thumb in the direction of the particle's motion. That would be pointing to the right, and then somehow I have to contort my fingers, which are the B field, in the same direction, and I just can't do it, which means the backhand doesn't have any force on it. Good. Thank you. And can everybody down at the very bottom, the reactions, you see a little smiley face, can everybody clap for Kevin? Thank you. Yay. Awesome. Yeah.
Why isn't there a bad reaction?
Bad reaction. I don't know. There's no bad reaction. You did a great
There
job.
should be. That was pretty bad.
No, that was great.
How-
Okay.
what's the reaction?
Okay, so now we're going to do number 2.
Yeah.
Number 2, kind of same idea. So I'm going to go ahead and open up the breakout rooms. You guys go ahead and go on in there.
Oh, clap.
What? Okay. How'd you guys do that? Asking for help.
There's a little button on the bottom of the screen and it says ask for help. And
Nice.
it
Okay.
says, do you want to invite the host?
Nice. Okay. So, because we couldn't figure out how to do that in another class. So, all right. Yeah. You have a question for me?
Yeah, for number 2, so we have into the page. Would that be right?
Let's see. There would be, this is a positive charge, so thumbs upward. Our fingers would be toward the right, and our palm is for positive charges. So yeah, I think it is into the page. Into the page.
Okay.
Yep.
So if it's negative, you use your the outside of your hand?
Yeah, it's negative, so you backhand it. It's nasty.
Okay.
Yeah.
So if it was an electron, then it would be out of the page?
It'd be out of the page. Right. In other words, so what you draw then, if it's out of the page, you draw a dot. That means it's coming out toward you. If it's into the page, you put an X.
Okay. That makes sense. Thank you.
Yep, no problem.
Thank you.
Bye.
Bye.
Have you guys used breakout rooms in any of your other classes for Zoom or anything?
Yeah.
Sometimes.
Yeah.
Calculus.
So what do you, in your other classes, do you have a whiteboard that you work on, or you just go in there and talk?
Well, for like calculus, she posts an FRQ on the calendar and everybody just works on it on their own and then shares and talks about it.
So you're not working on the same area. I mean, you're able to talk, but you're not able to work on the same thing.
No.
Okay.
We've also done like quizzes things, just for a bunch of like multiple choice questions to run through at the start of class.
Oh, I got you. Okay, so like he or she will show you like a question and say, okay, go in your break rooms and talk about it and figure out the answer.
No, like Quizzes, the website.
Oh, quiz is the website.
It's like Kahoot, but each person can see the question individually.
Oh, okay. All right. I guess I don't know what that is. I'm going to check that out. I've heard of Kahoot, but I don't know quizzes. Okay, let's see. I think everybody's back now. So, all right. So, does anybody want to share their whiteboard with us? By the way, I looked at all the whiteboards, and there was lots of different answers. Believe it or not, there was people who had said both. I think there was somebody that said. I think there was somebody that said no force. Another one said, I think, to the left. I don't know if anybody said to the right for the force. There was quite a few that had both into and out of the page. So there's lots of discrepancy here. So it's okay if you have it wrong. So whatever you have, let's see what you got. Somebody going to present. Miranda, thank you. And just kind of talk us through how you were able to solve this one, Miranda.
So the thumb follows the proton up the page, and then your fingers go to the right, which means that your palm is facing into the page.
Good. And if it would have been a negative charge, then you do the same thing, but you use the back of your hand because it's negative. It's nasty negative. You backhand it. Right.
Yep.
Good. Any questions? Okay. Now there were some groups that had it. I remember there was one group that had it to the left. Does that make sense? Okay. All right. So I'm going to go ahead and form breakout rooms. You're doing number 3 now. Adam, did you get a join me code for? Oh, I can't hear you. What'd you say? Oh, there he goes. Okay. Hi.
Hi. We're wondering about for number 3 if we did it right or like because we had like the current going this way and then like the B field going up,
Right?
so it would be out of the page.
Yeah, so it's coming toward you. So the wire is going to get forced toward you. I don't know if you could. That's kind of what was happening when I showed my demonstration in real time. I don't know if you saw it when I connected the circuit, and all of a sudden the wire kind of moved a little bit. So yeah, this wire would move. It would jump toward you.
Okay.
Yep.
Thank you.
Yep.
Thank you.
We're still waiting for everybody to join us from the breakout rooms. Okay, so I think everybody's back. So any questions on this one? So instead of having a volunteer this time, I'm just going to call on somebody to see if they're here. So since there's a couple of people I can't see, how about Christian? I would like you to share your board with us. Don't be shy, Christian. I know you can do it. There you go.
Yeah, I'm already.
So walk us through, Christian. Tell us how you figured this out.
Well, in this case, basically what I was trying to do is just use the standard array hand rule that we've been using so far. And so basically if my thumb's in the same direction as the wire, then my palm would be facing like out of the page.
Okay. So the thumb is toward the right and the fingers are toward the top of the page. And so your palm is toward your face. So the wire's going to kind of jump toward your face. All right, everybody give Christian a hand. Nice. Yay. Yay. Awesome. So Christian, if you can stop sharing now.
All right, how am I supposed to do that here?
I think there's we're up by the green thing. I think it says like
Yeah, it should be up top.
yeah.
Up by what green thing here?
I think there should be like a stop or something.
I'm not
Not
seeing
seeing
any
it?
stop.
Okay, let's see if I can here.
Move your mouse.
I was able to do it. I could do it.
Okay, there we go.
So I'm learning too. Thank you very much, Christian. And now we're going to be doing problem number 4. So let me go ahead and put you in the breakout rooms.
Mr. Infested, do we just assume that it's positive, or
For number 4,
it doesn't really explicitly say, so I was like,
number 4, yeah, it shows you the picture is not positive, it's negative, isn't it? That's a negative charge.
no, number 3.
Or excuse me, number 3.
The one we
Oh,
just,
yeah, that's a wire, and we're
okay, because it's a wire, it's always positive.
well, conventional charge is always
Yeah.
positive. Yeah.
That makes sense. All right, cool.
Yeah.
Thank you.
Yep. I think everybody's back now.
No.
Okay, so let's see. How about Spencer? How about you share? So at the bottom, there's a little green share, and then the blue share. Oh, you're the one that had the pretty arrow. Wait, I thought I saw a pretty arrow. Nope. Okay, so up. So Spencer, walk us through how to do that with the right hand rule. Tell us where we point our thumb and finger and all that kind of stuff. You might have to unmute yourself.
There we go. Okay. So we have our thumb going into
the page.
the right
Okay.
hand rule, and then that will have our palm facing upwards. So that's where the force will be going.
Gotcha. That would be a force on what kind of particle? Positive or negative?
Positive.
Yeah.
Yeah, so if this is positive, yeah, it would be forced up, but it's negative. So if it's negative, you know those nasty negative, what do you have to do with it?
Backhand them.
Backhand them, right? So it actually moves downward.
Okay.
Cool. Thanks for sharing. Thanks for sharing. Everybody give Spencer a hand. Give him a hand. Yay. 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 Nice. Okay, so let's see if we can get another one in number 5. So let me open up the rooms again.
Okay.
Okay, I think this is going to be the last one. We're going to share, and then I have to kind of tell you some stuff, and that'll be it. So as soon as everybody gets out of here, out of the breakout rooms. Okay, so again, I think this is going to be the last one we do, but then I have to share with you some stuff that you still need to do, and that'll be the end of it then. So does anybody want to volunteer for this last one real quick?
Yeah, we could do it.
Yep, okay, thanks. Okay, Josh. Oh, you guys are the ones that have the nice, pretty arrows. Look at that. Huh? That's cool. So walk us through how you did the right-hand rule there so everybody can practice it.
So we said thumb was pointing to the right,
Okay.
and the fingers for the B field were pointing out of the paper, so towards me.
Okay.
And that left my palm facing down.
Good. So it's a positive charge, so this charge gets forced downward. Perfect. So if you can stop sharing.
Oh, yep.
The whiteboard. Okay, I need to get another kind of a snapshot for attendance again. So Adam, Christian, come back so I can get your lovely faces. Thank you. So, oh, so I didn't give you a heads up. So how about a count of three again? 1, 2, 3, smile. All right, there we go. All right. Oh, sorry, I forgot to give you count of three. That's bad. All right, okay, so now I need to tell you what you're gonna do. So let me share my screen with you. Couple things. There is kind of an attendance wick. I forget how many questions there are, 5 or something. Mostly it's dealing with the right-hand rule, kind of like what we've been practicing. But you also have to, there's a couple, I think there might be a couple equation ones where you have to use the magnetic force on like a wire is equal to Bilson, which is B times the current I times the length, times the length, times the sine of the angle theta, where that angle theta is between the B field and the current. So angle between B and I, or I guess you could say the length of the wire too, okay? But I haven't told you, what about in the cases like this where you don't have wire, you have a charge? Well, it's still the same kind of idea. You're still going to have the force. There's a force on this charge, and it's going to be directly related to the B field. But it doesn't really have a current. I'm hoping you can see that that current, I probably should go back up here for current, which is amperes. But if you're thinking about, for the first semester, remember when we were thinking about charges? It's charges per second. So imagine that you're multiplying by a charge here, Q. I can move the seconds underneath the length. So length divided by time is, what's length divided by time?
Velocity.
It's velocity, yeah.
Velocity.
So the equivalent equation for a particle isn't Bilson, it's QVB or BQV, and then times sine of theta. So that's the charge equivalent one. So a lot of it's going to be practiced in the right-hand rule, but you might also have to use these two equations too. Okay, so let me go back to the Kevin's calendar. I have to give you the code then. So let me do that. 5 questions. Okay, so I'm not sure if you can see that. It's the tilde symbol, which tilde, for me, it's kind of near the upper left. It kind of looks like a little squiggly thing. 4, 3, uppercase U, lowercase f, uppercase L, lowercase q, 4, and then the star symbol kind of above the 8 there. So tilde, 4, 3, uppercase U, F, lowercase f, uppercase L, lowercase q, 4, and then the star symbol. So let me stop sharing. So any questions? So don't forget, internet homework's due on Sunday. Again, you only have to do 6. On Monday, we have another one of these Zoom meetings. I hope to continue working on the whiteboard so you don't need to work on it ahead of time if you don't want to. And if you are going to work on it, please work on it together, kind of like what we did here. Maybe you could start your own Zoom meeting or something. I don't want you to think of it as a hoop to jump through. I want you to learn from it. That's why I want to do it this way. Also, Friday is office hours, so if you have questions on the internet, homework, or whatever, you can stop by. Okay, well, that's it. See ya.
Could you go over the last one from Monday, Swift?
Oh, yeah, I can do that. Yeah, if you
I
want
had
to
a lot
stick
of trouble
around.
with that.
Yeah, if you want to stick around, I can kind of go over that real quick. Okay, so let's see if I can share again. So let's see how I can do that. It's the 13th. Trying to figure out how I can do. Oh, I can do a preview, and then I have to do it. That seems awfully mean. Okay, just this last one, right?
Yeah.
Okay, so let's see if I can create another Google whiteboard. That way you can kind of see my work. Come on. Okay, so let's see. I think I'm going to put this over here if it lets me. And then I'll go to the quiz. Yay, there we go. All right, so I want to figure out what the total magnetic field is kind of in that shell region. So let's see if I can do a snipping, and I'll put it over here in the whiteboard. There we go. For this, my Amperian loop is going to be kind of in this region here. All right, so I just want you to be able to visualize it instead of me just talking at you and lecturing to you. It's kind of enclosing two currents. It's enclosing this middle current inside of here, and then part of, not all the current, but part of this outer one here. So when I do Ampere's law, on the left-hand side, after I do the integration, it's just simply B times, well, all the way, the line integral here, well, that's going to be a circle. So that's the circumference, 2 times pi times r, little r. And then on the right-hand side, it's going to be mu naught times the quantity. Well, there's two currents here. The inner one, it's the full amount of that current. So that's I naught, or I0, I should say. I0. I'll just say I. But the other one is not the full amount, plus it's in the opposite direction, so I have to go minus. And it's going to be I times, it's going to be the ratio of the areas. So the area of the Amperian loop would be, let's see, that's going to be pi times little r squared minus, because it has this hole in the middle. So minus pi times, let's see, I think they're calling that R2. So big R2 squared. Does that make sense so far? Miranda, you okay with that so far? I'm not done with it. Okay.
Yeah.
Okay, divided by, here, I have to finish out the ratio of it. Divided by, let's see, it's going to be the quantity pi times, now for the entire thing, it goes all the way out to R3. So it's going to be R3 squared minus pi times R2. That's the whole inside. So R2 squared. So when I take that whole ratio there, I should put another parenthesis. When I take that whole ratio there and multiply it by I, that will tell me the amount of current in the outer part that's contained in my Amperian loop. Okay, so I can, there's a pi in the numerator for both the terms and a pi in the denominator for both terms. So I can actually divide by pi over there. Oops, I forgot the minus sign. And now I can just kind of solve it. You have to be careful here because it says that the radii are given in millimeters. So all of the R's you put in, for instance, the one I'm looking at here, it says the inner conductor has a radius of 1.7 millimeters. The truth is I won't even use that 1.7 because all of that current, that corresponds to this current here, all of that current is contained. So I'm not even using that. What I'm using is the 3.2 millimeters. That would be the R2. And I'm using the 6.9 millimeters because that would be the R3. And I'm using the 5.2 millimeters because that would be just my little r. So I don't know, does that make sense? I can go further and solve it.
No, that makes sense. I think I read the question wrong.
Oh, okay, all right. So, yeah, if that's all good, if that answers your question, okay. So, do you want me to open it back up for you?
Oh, that would be nice, yeah.
Okay, yeah, I'll open it back up for you. All right, see ya, bye.
Thank you.